All right. Hello, everyone. Greetings. It is October 15th, 2025, and today I'm going to be doing a Cascadian Synergetics live stream. It's going to be based around the slide deck of the name Cascadian Synergetics, which is created by Kirby Earner. And let's just jump in. If you're watching live, definitely write a comment or a question. Should be pretty fun and hopefully quite epistemic for us all. So I'm popping over here. Here we're in the Codecombs. We're in the art related to the Department of Synergetics Education. Lots of images to load. And we're in the meeting repository where every week for 18 months or so, and discourses along the way, correspondences before and along the way, Kirby Earner and I have been meeting and discussing a variety of topics, all open for your perusal. So here was last Tuesday, earlier this week, talking about ants, bioregions, all these different topics. And a core theme is Cascadian Synergetics and all these fun attributes about it. It's live streamed, we're open source, in process, in progress, it's off the cuff, it's in the ballpark, and Kirby has produced a very interesting slide deck, as with many of these slide decks, which is accompanied by tips for presenters. So that's this YouTube video here from a couple days ago. And in the info box for these slides are some tips. The video gives tips as well. And the point is, this is a slide deck which you can make a copy, you can fork this, or you can give it as is. So that's largely what I expect to do today. I'm going to go through kind of slide roulette style, go through these slides, maybe some diversions, discursions along the way. Mainly, though, just working with these slides, looking at the contents of the slide and the extra sections down at the bottom, working with this material and talking a little bit about Cascadian Synergetics. So just reading this tip box on the bottom, which I won't read for every single slide, but some of them there's great info that will help prompt going through this. Originally developed for Mount Hood Community College, MHCC. Dead Mathematician Society as a possible presentation. Internally MHSS, Mount Hood Synergetic Symposium. After a preview screening on October 8th, 2025 by Kirby, it was deemed too high level for the intended audience and more appropriate for grad students perhaps in computer science. The deck itself remains a usable artifact for those of us on the road. And there's a link to the My Bismo. So let's head over there. For those not familiar with the Kirbyverse, the way I recommend to interact with these blogs is go to the top level, Bismo Diaries, and then in other tabs, just hold down Control and open up the other three. So there's 4 main blogs. Bismo, Diaries, Business on the Go, Grain of Sand, worldgame.blogspot.com, Control Room, and Coffee Shops Network. And they're all kind of rotated between and among. So just open them up and go from there. Okay, let's jump in now to Cascadian Synergetics, and I'll try to stay on the main line so that we can get through these slides, even if we go over some with just a brief glance. So what is Synergetics? Yes, it is the title of one book. It is a 2-volume book written by Buckminster Fuller and Ed Applewhite. More on that later. It's also more than a book. It's more than one book. It's 2 books, and it's a discipline. there's multiple namespaces, and this concept of multiple namespaces is going to come up again and again. So different ontologies, different lexicon, different shop talk, the way that Herman Haken talks about synergetics and how that relates to the way we're going to be talking about synergetics here. And on this bookshelf at Kirby's house is some other books: Buckminster Fuller on Education, Critical Path, Anthology for the New Millennium, bunch of other work in the Fuller portfolio. And interestingly and critically, Synergetics is co-written with Ed Applewhite, which comes back a bunch. So what is Synergetics? I mentioned some of those on the previous slides. It is a collaborative work, which Ed Applewhite remarked on separately in the Cosmic Fishing work. It's a work that, as we will describe and explore, is situated in this very different and unique way, relating to the philosophical aspects and the humanities, and also the comprehensivist, that's kind of a C.J. Fearnley call out, to multi and transdisciplinary studies. It has a precise and highly structured nature, analytically and also in the prose, yet it is mostly prose, often with some common words getting used differently, some uncommon used words using them conventionally, all these different fun linguistics which are based around this geometry of thinking. And for the listener and for the inquirant to explore, is it wild, is it useful, where are we getting epistemic and pragmatic value out of this? Applewhite wanted to distill Fuller's thinking to a pure essence or core discipline. I guess it took the kind of mind like Applewhite to really stick on through and bring these books out. Here's an example of the flavor of Synergetics. So the sections are from paragraph length to sentence length. They are organized according to this decimal point-like notation that is not exactly linear, but it's linearized, if only for printing, if not for deeper numerological significance. And here we see Scion, which is kind of a Zion play by Kirby and connects to this cognitive unit, this conceptual element. And we see in this 1005 section a lot of characteristic ways to talk about comprehending and putting omni as a prefix in front of words, describing all these kinds of big topics: truth, love, linearity, embracing. And also on the top right of some of these slides, you'll see that they can go off into other directions. So where it says link slide, this is a hypertune. And you can pop over to slide 10 of the cultigory theory and see a little bit more what is being meant here by Scion. So I'll try to go mainly vertically, a little bit fun though to explore the lateral directions. So that's what the work itself is. And this presentation, as the two words would have it, are going to be about what is synergetics, what is that technical essence, and then how does it relate to Cascadia? What are we doing out here? 4D was a big meme at the beginning of the 1900s. This was a drawing that Buckminster Fuller made in 1928 that was adopted to characterize his fourth dimensional mathematical explorings. And you can see that's in Synergetics section 986. You can also see it, of course, on the live stream that I'm doing right now. It's a great image. It's a timeless image, fun to use. And here's ways that even more recently and in the decades since, we have all of these explorations, and there's deeper aspects to go into with how is dimension being used. And so this topic of dimension in Synergetics is going to come up today as well. Here's a quote from H. Coxter, who wrote, "Little if anything is gained by representing the fourth Euclidean dimension as time. In fact, this idea, so attractively developed by H.G. Wells in The Time Machine, has led such authors as J.W. Dunn into a serious misconception of the theory of relativity. Minkowski's geometry of spacetime is not Euclidean, and consequently has no connection with the present investigation." So this is Coxeter, geometer, describing the inequality of the Einstein 4D, the Minkowski space, with the extended Euclidean multidimensional. And it comes to this multi-namespace topic. 3 meanings of 4D that are going to be juxtaposed here and woven together with a special emphasis on the third one. First, 4D in the sense of polytopes, that's Coxeter's definition, and refers to this extended Euclidean framework. So that kind of point, line, plane, keep on going way of thinking about these orthogonally related flat planes. Then there's 4D in terms of relativity, bringing a time dimension and all these other physical connotations in. And then lastly is the synergetic 4D, which is focused around the tetrahedra as a minimum shape and brought to the fore by Buckminster Fuller. Here we see some special people and moments from history. On the left is Gregory Hinton, one of the influential characters in modern AI research. Coxeter, up here. Bucky and the CIA's Ed Applewhite, plotting. And Fuller dedicates Synergetics to Coxeter. Pulling back to this geometry of lumps. So, Euclid's assumption, some of which he never stated explicitly about points, lines, and planes, involves a twofold idealization of the relations between small dots, rigid rods, and flat boards. First, he neglected the extension of the dots as well as the thickness of the boards. Second, he assumed the length of the rods to exceed any finite bound. So, I venture the conjecture that for the geometrization of physics, especially the physics of the microcosm, idealizations very different than those of Euclid might prove more adequate than his. In this kind of point-line plane abstraction setting, first there's a point, as whether you think of it as 0 or one-dimensional, but it's there, but it's nothing. It's referencing a point in space, but there's nothing there. And then we get lines, which are constituted of points, and they're kind of invisibly like a laser, but with no thickness, cutting through space. And then we get to the plane, point to line to plane. Again, the kind of Kandinsky approach, though he was coming at it from an artistic side. And then a plane is like a line swept out, and it has no thickness. And the idea that has been hit upon qualitatively in this geometry of lumps, but then gets extended into its quantitative and system scientific setting with synergetics, is no, actually for space filling, you need to start with a minimal physical space enclosing system, the minimum of which is the tetrahedra. So that's one of the reasons why fourfold partition and the tetrahedra, the 4-event system, is primary, because it is the simplest space enclosing space. And then you get points appearing to a given individual like little specks of dust as a very small space enclosing system. You can get things like rods and sheets of paper, which have special extents. A sheet of paper is very thin relative to how long and wide it is. However, it still does enclose space. So this is going to give us a sort of radical embodiment, because built into everything we're going to be discussing about tetrahedra is we need it to enclose space, and we want our geometry of cognitive cyber-physical systems and everything like that to be built around this idea of space enclosure, not have this kind of characteristic cube imposed over a system built upon a foundation that is invisible. So what would that really mean to look at another system alongside the cubic-centric model? What would it mean to have this tetrahedra serve as a unit volume? Well, there's a few ways to look at it. One of them is that you can think about a tet inscribed within a cube. And there's actually another tet inscribed the other direction of the cube. That's what Kirby's logo is over there. And those tetrahedra end up being kind of like structural stabilization on the cube. And so that's one way to look at the equivalencies, is we get all the 8 points of the vertices of the cube, in terms of these two interpenetrating tetrahedra. And so those are the points of equivalence. So that's how the vertices line up. Another way to look at this is in terms of these kissing spheres, close-packed spheres. And in that situation, you can think about spheres, marbles, cannonballs, what have you, oranges, with a radius of 1, arbitrary unit of 1, and therefore the kissing distance between the close-packed centers, or across any given sphere, is 2. And we can set that 2 to being the diagonal length here, and that gives us a root 2 for the non-hypotenuse edge of this situation. So that's the rationale for saying that this distance of the sphere is 1 because we're in a close-packed spherical geometry. That's the isotropic vector matrix, or the IVM, is this kind of infinite matrix or ocean of close-packed spheres. And we can then set the distance between them as 2 and use that as the diagonal to give a nice integer scaling and a lot of other features to the volume calculations associated with a tet and a cube. And this is going to come up again with the Synergetics constants. So why are we doing all this? Don't we get good and easy multiplication by talking about the second powering as squaring and the third powering as cubing and all of that? Well, it turns out that those properties, which are often associated with rectangular graph paper or with rectangular blocks, like second powering being the number multiplied by itself, the third power being the number multiplied by itself 3 times, that's not in 2 dimensions just a feature of square graph paper. It's actually a feature of counting the cells in a triangular graph paper. So we could think about squaring as being quadrangular accounting, whereas triangling would be triangular accounting in the second power setting. In the third power setting, we have cubing. We can also talk about tetrahedroning because it exactly works the same way. So some of the properties that are commonly positively associated with the cube, turns out they're also just associated with space overall. So back to 4D. It's a language game for the tetrahedra. When we're talking about 3D, 4D, we're playing with these language games, these shop talks, these namespaces, and those rely upon, implicitly or explicitly, quite a metaphysic, literally a metaphysic. In terms of changes in that metaphysic influence our physic, how we think about the world. So here's a quote from Synergetics 527. Geometers and schooled people speak of length, breadth, and height as constituting a hierarchy of 3 independent dimensional states, 1-dimensional, 2-dimensional, and 3-dimensional, which can be conjoined like building blocks. But length, breadth, and height simply do not exist independently of one another, or independently of all the inherent characteristics of all systems, and of all systems' inherent complex of interrelationships with scenario universe. All conceptual consideration is inherently 4-dimensional. Thus, the primitive is a priori 4-dimensional, always based on the 4 planes of reference of the tetrahedron. There can never be less than 4 primitive dimensions. Any one of the stars or point-to-able points is a system, ultra-tunable, tunable, or infra-tunable, but inherently 4-dimensional. So that's too small to be seen, or too big to be seen. Imagine a tet that's so large it just looks like a open field in front of you. And then also this line right here, all conceptual consideration is inherently 4-dimensional, is where the geometry of thinking and of the connections between active inference and cognitive science and synergetics come into play, is this 4-fold partition and this idea that cognitive systems are systems, systems are embodied, they are actual, even when they're cognitive or metaphysically proposed. And that means they need to have this space-filling instantiation. And so it makes sense to have the primitive be a priori 4-dimensional, as opposed to, say, cubic. Fuller is not the only one who has questioned this idea that space is three-dimensional. And so here is a letter from the morphologist R.C. Thompson to Whitehead that was written in May 1918. And it's an interesting letter to read. One of the things that he writes is, "Paradox or no paradox? Isn't that a paradox? I seem to be driven to the conclusion there is a quibble or even a fallacy underlying our definition of space or of dimensions. Perhaps both. Perhaps that dimensions are not necessarily rectangular, or that perpendicularity inter se is not a fair condition to postulate of them. That the space which actually exists is quite independent of dimensions, and that by appropriate transformations we may ascribe it to as many as we please." Which brings us to, well, what coordinate system? Once we come to that Chris Fields-like understanding that space and time are our metric, our projection of a coordinate system, reference frame, quantum reference frame, on what may or may not have a true, if that could even be said, underlying dimensionality. Regardless, we interact with it through our proposed coordination system. So what does an alternative coordination system look like to complement with the XYZ orthonormal perpendicularity predicated coordinate system that we're mostly inundated by? That is where quadre coordinates come into play. So quadre coordinates, there's a bunch of different ways to think about it. It's the center of gravity of a tet, regular tet, and then the vectors that point to each of the vertices are given a length of 1. Another way to look at this is you take 4 spheres, 4 marbles, and you close pack them, and then the gap in the middle is the origin, and then the vectors are going to the center of those spheres. So any 4 close-packed ball centers that define a tetrahedra define a whole number volume versus the regular 4-ball tetrahedra of volume 1. More on that is in this dimension in Synergetics. And once you're working in that setting of close-packed spheres, you get to work with all of these different space-filling shapes, like the octet truss, like different integer sequences associated with the shells, the nuclear series, growing of different shapes, and they have these really nice, simple, all-integer accounting values. Now, Kirby interjects here with a little bit of his own history. So we have Richard Rorty and Walter Kaufman, 2 of Kirby's professors at Princeton. There's young Kirby. And Earhart of EST Est fame, and Bucky. Kaufman again, and Nietzsche. These are different avenues. Definitely check out more about what Kirby has said to all of them. And a slightly older Kirby, continuing his journeys. More people. Later, Kirby turned towards open source community and Python and a lot of other activities in Portland, leading to these fusion artifacts, which are computational. They're notebooks and they're Python scripts that relate to quantitative ideas from Synergetics and the quadres, which are not in Synergetics, but other a natural coordinate system that was built afterwards, with some of the people already seen and other collaborators, and always characteristically, whimsically though, quite seriously, put in terms of the humanities. So, Python meets Wittgenstein meets Synergetics. There we have Wittgenstein. And quadres, working with them, is ultimately, essentially, vector work. So It is possible to operate this in the script forming or in the notebooks, but big picture, these are vectors, and they are subject to rules of vector calculations. So here we kind of take another dip into the cultural, into a quadre coordinate specific deck. And we can imagine that these are different sort of series of societies or subcultures. So they all have this common idea where they have 0, 0 defined as their origin point. And then they use non-negative vectors that are maximally spread apart in order to talk about their coordination system. So in the bi-vector, the 2 vector setting, you get these 2 vectors going to 0, 1, and 1, 0. Notice that this isn't 1 and -1. This isn't spreading out on a number line. This is all positive coordinates, and they're just going in different directions. The 3 vector setting gets this plane. So this is also, interestingly, like this is when carbon engages in 2 double bonds or a triple bond and a single bond. And then we have the 3 vector case, which is like a carbon with 1 double bond and 2 single bonds, which makes this triangle planar geometry. And then we get to the methane, the CH4, the all sp3 hybridized carbon, where we get maximal repulsion of the hydrogens, and that gives us this tetrahedral geometry with the quadre coordinates. So again, it's not that the tetrahedron is superimposed over an XYZ coordinate system, where, for example, this point A might be 1, 0, 0, and then these other points B, C, D would be like negative on the first axis going up and down. But rather, each of those 4 points pointed to by those vectors A, B, C, D have a positive value. So it is vector math still. They still add. They still do all the good things. They just have this coordination that is more like a methane molecule. And this is a screenshot that was from before the math forum was nuked. Looks like it was hosted at different places, and this is just one of the many internet artifacts, and that's why we're always doing ethnography, nesting, weaving, linking, showing, because we really, even when we try to take matters into our own hands, we can never be sure about the longevity of material online and the veracity of it. So we do what we can to document, and when something like this goes away, if it really isn't available anymore, it's a tragedy. Quadre coordinates have a Wikipedia article, a short Wikipedia article, but it does link to several Kirby and several Tom Ace references, and to American transcendentalism philosophy, and so this is something that could probably get expanded on. And it has different sections. Here we have an animation that I commissioned. It was a 3-dimensional visualization of a person in this posture where they are stepping forward into a lunge and they're holding their arms out to either angle. And this is demonstrating that our body is like a mnemonic for understanding the vertices of the tet. With these 4 points, we have a person inscribed within a tet, and that is the tet, which is the equivalence point or the Rosetta Stone between the tet and the cube. So, is it really a cube? Is this person within inside a tet, or are they within a cube? It's both. It's the same exact vertices. That doesn't matter for the demo, as a first step is to become oriented. Fine-tuning is later. So this is one color coding of kind of a chirality for this tet. Super cool to see. Greetings, Kirby walking the dog, indeed. All right. Here, 27, is the bidirectional methods one implementation of them each to go from vector to quadri-vector and quadri-vector to vector. So this is the Python code laid out there. With a picture of some C60 balls that are outside of Kirby's home, there's more images here reflecting how the kinds of multiplication operations that can happen with a tet in this IVM space are happening in this close-packed spherical geometry. So that ocean matrix of balls close-packed is called the IVM, isotropic vector matrix. C60 is created by Sam Lanahan. And so here's some more history, weaving on back through the Fitzgeralds and Fuller. Then to stay with that geometry and also look at what was happening concurrently in American history is Genius at Work, Images of Alexander Graham Bell. And right there on the cover, with a prologue by Buckminster Fuller, is a tet with that octet truss. This is a animation. It says vector addition using the rule of 2 of one quadre, 1 of 2 others, and none of a fourth. So those are choice rules for movement within this quadre integer accounted space. The 12 combinations take us in hops from 0, 0, 0, 0, the origin, to each of the 12 corners of the volume 20 cuboctahedron. So those are ways that with those choice rules, moving 2 of one, 1 of 2 others, and none of a fourth, it's kind of like a knight's tour of a chessboard. You hit every vertex in this cuboctahedron. And that's kind of like a turtle bouncing around, or like a point bouncing around in this discrete lattice. Here's a Python code algorithm for generating the next layer of the CCP, the close-packed geometry, packing outwards from a nuclear ball. So 1, then the second shell has 12, third shell 42, 92, 162. So those are familiar to the nuclear chemists out there. And it uses the 12 permutations of the 2, 1, 1, 0, mentioned on the previous slide, to vector add to the surrounding balls in the outermost layer so far, keeping only the balls not so far seen, using a keeps unique only Python set data structure to give a next layer, and so on. So this is just to show that you can be within a given shell, whether it's just one sphere at the origin, or whether you're at a higher frequency already, and then you can iterate until you saturate that next shell, and they're all visitable using this 0, 1, 1, 2 addition. Here is the next layer function, which is a function of the current layer and the previous layer, and it's a confirmation that the number of balls in the successive layer has that nuclear patterning 12, 42, 92, 162. This is a 2 frequency shape, vector equilibria, shells building out, 2 frequency, 3 frequency, 4 frequency. And those are linked in the quadri coordinate slides. Now we turn to another geometer and crystallographer, Arthur Loeb. So here's a quote. In 1960, at the International Conference of Crystallography, took place in Cambridge, UK, I felt like a real iconoclast in presenting an alternative to the cubic unit cell, so sacred to the crystallographer. When I had finished my presentation, I saw Elizabeth Wood, head of the U.S. delegation, charging towards me. Somewhat apprehensive, I was surprised to hear her say, "All my life I have wanted to say, 'To hell with the unit cell,' and now you have done it." So that's talking from a crystallographer's perspective about, well, what if it wasn't a cubic cell that everything else had to get shoehorned into? What might it be? What might be an alternative, if only at first? And then what might be maybe even a more natural setting, for example, close packing. And here we have a repeat of a previous slide. And this helps give us a new lens, a new layer of paint on why the cuboctahedral and the icosahedral sequences have the same geometry and the same number of spheres included, and that's this online integer sequence. Um, Continuing on, it's not just that individual shapes, as we grow shells on them, have nice all integer properties. It's actually that there's a very fascinating, mostly integer accounted concentric hierarchy that's based around how these shapes all nest from a common center of gravity. So we have a tetrahedron with a volume of 1, cube, volume of 3, octahedron with a volume of 4, vector equilibria with a volume of 20, and some other values that are described here. So these shapes fit into a concentric hierarchy relative to one another, and some of the polyhedrons have satisfying whole number volumes. Whereas if you're in Cubelandia, wherever that is, you're going to get the cube with a nice volume of 1, and then other shapes have all kinds of different fractional fictitious values. Whereas when we're in this integer scaled system of volume predicated around the tetrahedra in Synergetics, we get all these different nice integer valued, and where not integer valued, very nicely symbolically describable volumes. Here we see an image that we've seen a little bit earlier. Often this math is called Martian math because there's like a sci-fi cult around reuniting with our Martian colleagues, and they've already been using this math, and so we're using the XYZ at that moment in the story, and they're using the IVM and the Synergetics, and so we bridge and we communicate that way. And here's demonstrating that multiplication in 3 dimensions, that you can do that from a 90-degree corner, or you can do that from a 60-degree corner. Basically the 3 lengths of the tet, and then close the lid, and you get the volume in unit tetrahedra. Just like if you had a 3 by 4 by 5 rectangle, you could go those 3 distances in the XYZ, and then you close up all the lids, and in the cubic volume normalization, you'd get just those 3 numbers multiplied together as the volume. Here's alternative tetravolume volume formulas for tetrahedra. So these are ways to calculate volume where the unit tetrahedra with that quadra at the center has a volume of 1. The first formula is the tetravolume defined by the 4 corners expressed in quadra coordinates. The second formula has edge lengths as input, derives from Cayley Menger, which is consistent with Piero della Francesca's work from the 1400s. And also Gerald de Jong has done some work on this, and there's a bunch of notebooks and code and more information about this. So whether with the quadra vectors or with the edge lengths, it's possible to get the tetravolume of a given tet. Here's one way to think about, again, this kind of duck-rabbit situation with a tet and the cube. So here's a cube with edge r. Here's a tet with edge 2r, because it's the r is the radius of the closed packed sphere. And in the cube, the XYZ volume is 1. Again, that's kind of the XYZ water we swim in. 1 edge length, 1 to the 3rd power stays as 1. In the IVM tetra volume normalization, the root 9 over 8 is the volume of that cube. And it's basically like vice versa on the other way, which is in the IVM setting, the unit tet has a volume of 1. That's the tetra volume. And within the XYZ volume scaling, it's root 8 over 9. So that's off by this factor, which is called S3, Synergetics constant in the 3rd power, which is 1.06066, and sometimes referred to as get your kicks on route 106.066. This is a classroom, looks kind of interesting, at Reed College, where Martian math was taught on the Saturday Academy. And this is a TET built up of the 24A modules. So the TETs are useful to assemble upwards, but also they get broken down into these sub modules, which more to come on that. And what's happening in each of those modules is basically the four sectors of the TET are being separated, kind of the four areas that are getting swept out, the four wide tetrahedra that are getting partitioned from the unit TET by the quadrays. And then each of those four is getting split into six. Each of those flat TETs gets split into three sectors like a propeller, and each of those gets split in the middle. So that's how you get 24A modules. And here's a figure from Synergetics in 913 and some code that express the A modules in terms of the quadray coordinates. And you can compute their volume symbolically. You get 1/24th, as you should. And then this is about the B module, which is when you subtract out the A modules from this orthoscheme octahedron, you are left with the B modules. Here's A and B modules together, and these other extrapolated numbered modules. This is more about those modules and the way that, kind of like tangrams, they can recompose different shapes, and those have some certain volume properties, space filling properties. This is a table from the paper of Goldberg, 1974, 3 infinite families of tetrahedral space fillers. And the way that these plane net representations and tables that are summarized in that 1974 paper relate to the Synergetics namespace of talking about the might, which is this 2 of one and 1 of the other composition, concatenation of A and B modules, the right, the byte. Here is going back now to kind of looking across different shapes, not just decomposing them into their modules, is talking about the volume relationships within that concentric hierarchy and about which shapes perfectly nest within which shapes with which volumes when you scale it this way. And this looks like it's by Mr. Koski using the V-Zome. So people may be familiar with the V-Zome toy. It's not a toy. And it's physical materials that you can play with, but it's also a computational modeling toolkit. Here, now going to more modules, the T and the E modules. The T and the E have exactly the same shape, but volume to surface ratios are not constant. So that's kind of interesting, and these are like ways to peel off different modular shapes within and look at which shapes being accreted onto which shapes lead to which shapes to transform into each other. More tetravolume discussions within the concentric hierarchy. Fuller did not focus on all of these. Synergetics is still emerging as an area of exploration, indeed. Here is a twisted tale, a painful point for many in the community, where there was a number that was so close to 5, it felt like it just had to click to 5. The ratio was so close, and that's explored in this slide in section 986. Here's the S module and how it relates to the icosahedron and the octahedron. This is some visualizations by Casey House of Syn-U. More shapes, how they compose, how they nest. Here's 3D printed modules along with a nice Uniball pen from Multnomah County Library. Here is work from Koski more volume calculations with the S3 and the S6 in different module shapes laid out. More exploration about how looking at these volumes in normalizing them or looking for affinity between edge, surface area, and volumetric considerations show or obscure different, often all integer valued or kind of sacred ratio related relationships. Here's the unfolding of the edges. Nice GIF. That links out to the beast modules. So I'll just flip through the beast and the basket. You'll see a lot of similar themes, some slides copied, some different slides. This is a super useful image right here, showing a lot of the relationships amongst the different constants. Here is skewing the cuboctahedron, keeping the faces flush to the octahedron, results in another icosahedron with these nice volumetric scaling relationships. More rotating, shifting, scaling. This is the jitterbug. Here, in the sort of closing stretch, we return to this CP Snow idea of there being two cultures. Here's the prompt that was used to generate this image. Kirby wrote, "A deep chasm in the desert separates two groups of people. On the left, jolly jokers, wordsmiths, punsters, and poets. On the right, MIT engineers with pocket protectors and slide rules looking stern. The CP Snow chasm. The great divide between the humanities and the sciences." So kind of like the word cell versus shape rotator debate, as the kids might say today or maybe yesterday already. So how does that work? How are we going to gap respect, gap clear, jump, and maybe even bridge? Well, Synergetics does it. Here we see more history. Ezra Pound, Bucky, Ed Applewhite, and Ezra attending Bucky Talks, and also Isamu Noguchi here. So more history, connections. Those modules just described, of which there's a slowly adding zoo of them, is, well, a few years ago was mainly going by Beast, and then the K module was introduced with a double nod to Kirby and Koski, and that led to a transposition of the Beast into Basket. And here's some images that we were exploring maybe earlier this year or last year around this kind of basket steampunk where path and steam come together. And A could be inserted into STEM for STEAM for art, and also for anthropology in the path. Again, slightly different, but Ezra Pound again, James Joyce, and Kenner. So this kind of literary critical American lineage, and all these different transformations on the path of STEAM, STEM, bringing it all together. And that is where the slides take off with this kind of Wittgenstein related geometric path, basket, American history unfolding, happening among many other places in the Cascadian setting. So there's a lot more that could be explored. The video description of this video has some links in if you like art, some of it AI generated, but on a large variety of topics, then following the links into the Math for Wisdom Codecombs will be fun for you. And I guess as good of a place to close it is Synergetics needs you. So hopefully this is an interesting video. It's a little bit less than an hour. This is a symposium, which could be unpacked over multiple days and with a lot of links to the code and all kinds of stuff that could be done with embodied exercises and hands-on building, things that Stroopy is familiar with. All kinds of stuff could be added. It could be a day. It could be a season. It could be a year. It could be a degree. It could be more than that. So that's how we're doing it. That's how we're living it. And hopefully this has been interesting and useful for you. Thank you. Till next time.